Hello and welcome to Neon Math. Today, we are going to solve systems of linear equations, that's lines, using the method of substitution. And I'll show you a little graphing as well. Our first problem is right here. What I want you to keep in mind as we work through these problems is that when we are graphing a line, there is a format that we have been taught called slope-intercept form, where you have y equals something times x, and then usually some number following along at the end, positive or negative, doesn't or none at all if it's just zero. So occasionally I will think about getting things into this form right here, okay? Just put that in the back of your mind. Our first substitution problem is a pretty, I guess we would call it a more simple one, and it's because when we see the problem, okay, so we have two equations here. Each equation has two variables. The idea here is that if we only had one equation with two variables, we couldn't really do much with it. So to be able to solve for two variables, we'd really like to have two equations. And hey, look, here we have two equations. And ultimately, if I were to graph this line, and if I were to graph this line, where they intersect, that would be their solution, which would look like an ordered pair of x comma y. And that x would actually be what x equals in both of these equations. And that y would actually be what y equals in both of these equations. Okay? So when I'm looking at these two equations right here, and I'm thinking of substitution, what you usually want and need for substitution is you want one of the variables to be isolated. And in this case, I have y already by itself, y equals. So I'm ready to go. In the next problem that we do, it won't be that simple, so I'm going to have to do some playing around till I get something isolated. Okay, so this says clearly y equals this. Okay. So y is y, but y can also equal negative 7x plus 19. That's good to know. Are you saying that this y right here also equals negative 7x plus 19? Yeah, for this problem, yes, that's exactly what it's saying. Okay, so let me come in here. I'm going to rewrite this equation, but instead of putting a y, I'm going to plug in what y equals, which is this negative 7x plus 19. But why would you do that? Because if I can eliminate this y and plug in this instead, see, it's still 2 times y. It's still 2 times what y equals. If you look carefully, you will see that now this entire thing is in terms, well, it's just x. All I have is x's. And if all I have is x's, I can solve this. So let's go ahead and solve this. I'm going to go ahead and distribute this. I look in here and I can't combine this x term and this 19 because they're different families. But I can go ahead and break down the parentheses by distributing. I'm going to rewrite the 3x, don't lose it, plus. Now 2 times negative 7 is negative 14. I could write plus a negative 14. I just like to get in the habit of minus. I just do that myself. 2 times negative 7 is negative 14. 2 times 19 over here is 38 equals, still equal to 16. Now, anything that's on this side of the equation, I can go ahead and combine. So I could go 3x minus a 14x, and that would give me a negative 11x. Okay, cool. So I've made the decision I'm going to get all the x's on the left side, and I'm going to get all the numbers ultimately to the right side. That's just looks like the choice that I made. And I'm going to subtract 38 over here. Cancel that. And Okay, so I'm busting out my calculator because I don't feel like doing 16 minus 38 in my head. Ah, negative 22. Very convenient. Okay. And here I have my negative 11x equals negative 22. A small number minus a bigger number is going to give you a negative number. Now, last thing I have to do is opposite of multiplying by negative 11 is dividing by negative 11, and I'm going to do that to both sides, and I'm going to end up with a beautiful answer. A negative divided by negative is a positive, and 22 divided by 11 is 2. Oh, I know x equals 2. So originally I said these are two lines where they're going to cross, x comma y. I know now that the x part of that point is 2, and I still need to figure out the y. So I need to take this, and I need to plug that in, and I am going to take it, and I'm going to go, and I'm going to plug it in right there. All right? I'm going to plug it in. Now that I know what x is, I can plug it in right there. And so I'm going to squeeze it in. Okay, so y equals negative 7 times x, which I just determined is 2, plus 19. That's negative 14 plus 19. 19 minus 14, I like to think of it backwards like that, gives me y equals 5. I was a little messy, you know, math can be messy. And y equals 5. So now I know that if I were to graph these two lines, the point they would cross would be at 2, comma 5. So I found out that x equals 2 and y equals 5. In fact, I'm going to run over to my graphing calculator, Desmos, and I am going to graph the y equals 7x plus 19. It's this line right here. And then I'm going to graph the 3x plus 2y equals 16. I'm going to see where they cross. And they cross at 2, comma 5. Isn't that neat? All right, let's look at another problem. This problem was in a workbook. Somebody showed it online, and I don't know, just kind of the way that the workbook walked through it isn't exactly the way I would think of it or do it. So I need to isolate one of these variables, and just a warning, this is going to have some fractions in it, all right? But when we have fractions, we're going to want to do our very best to, well, eliminate the fractions if we can, not bring along too many fractions if we can. Sometimes we can think through a problem and avoid fractions. This one, we're not going to be able to avoid the fractions. All right. My choice, I want to get x or y by itself. I would probably, okay, so I'm looking through here. I like to go with positives. I have a positive 3x, I have a positive 4y. Either of those, I'd probably want to isolate myself. But just for the purpose of trying to show this kind of like it was shown in the workbook that I saw, I'm going to actually solve for this right here. They gave the advice like, hey, always try to choose your smallest, the smallest coefficient that you can. And okay, I can see using the smallest coefficient, but if the smallest coefficient is negative, I might not often go with the negative. And so myself, I might go with this positive 3 or this positive 4. But let's jump in and try this problem. So I have made a decision that I am going to solve this one, this top one, for y. Let's see what that looks like. So I'm going to rewrite it over here. All right. I want y by itself, so I'm going to take this and I'm going to subtract it to both sides. That's gone. I want to I want to keep this in that slope-intercept form, so I'm going to put the x term in the front and the constant term at the end. I just disciplined myself to try to always just put it in that form. Now, the opposite of multiplying this -2 is dividing by -2. And I am going to divide this -2 to each term. Now, in that workbook I was telling you about, they wanted you to divide it like this and then bring this whole thing over and go substitute that in. And if I was a student learning this, I'm thinking, I got to go plug this crazy thing in. Yeah, that doesn't work. That doesn't work for me. So I'm going to actually divide my -2 to both terms here. All right. This cancels, and I'm not happy about this fraction that I'm going to have to go plug in, but I'm going to do my best with it. So now I know that y equals 3/2x minus 1. All right. Now we can start the problem. Let's have some colorful colors. All right, I'm going to take this, and right here, I know that y equals 3/2x minus 1. So I'm going to take it and plug it in right there. I'm going to rewrite this whole thing. 4 times y, 4 times y, but instead of y, I'm going to put in this 3/2x minus 1. All right. Now I have some I got to use my math skills. I'm bringing along this -5x. I'm not going to lose it. But I'm going to go ahead and do distributive property here. 4 times 3/2. 4, really it's 4/1 times 3/2. And I just multiply across the top and across the bottom. Yes, you could cross cancel there. 4 times 3 is 12. 2 times 1 is 2. And 12 divided by 2 is 6. 4 times -1 is -4 equals -6. I'm going to combine any like terms that I can. Here I have a couple of x terms, so I'm going to go ahead and combine this and this. 6 minus 5x, or -5x plus 6 if you want to think about that. But 6 minus 5 is just 1x. I have my 1x. I'm going to lose that 1, but I want you to see it. Now I'm going to add this 4 to both sides because that's opposite operation. Inverse operation. That's how we do algebra. You can go back and see some of my older videos if you want to learn more about just basic algebra. Okay, opposite signs. So I'm going to subtract 6 and 4 and keep the sign of which number is bigger. So 6 minus 4 is 2. The 6 is bigger, it's negative, so my x is going to be negative. I have found the first in my x comma y. X equals -2. And now to end this problem, I just go take this -2 and plug it in right there. All right? And I can do that. So y equals 3/2 times x minus 1. I can put a 1 under there if it makes me feel better. 3 times -2 is -6 divided by this 2 times 1. -6 divided by 2 is -3. So this all boiled down to -3 minus 1 equals -4. And that's my y. So now I have found my y equals -4. We're putting it nice and neat there, so when our teachers correct in our paper, they see it right there. So now I have found the point where these two lines cross. Let's go check out Desmos, graphing calculator. If you've never used Desmos, just Google Desmos.com, choose the graphing calculator. They have a really cool free scientific calculator. I'm going to graph our first one, 3x minus 2y equals 2, and our second one, -5x plus 4y. I am going to, you can just click right right where they cross, and look, they cross at -2, -4. We checked our answer, and yes, we are right. Wow, we are doing really good, aren't we? All right, let's do, quote unquote, a real world problem. These are always, with systems equations, it's always like, oh, there's tickets and adult tickets and the kids tickets but this many, anyways, this many tickets were sold. It's kind of a formula. These are formulaic problems, and they call them real world. In this one, we work at a factory, and we sell tires. We sell bike tires and car tires. Well, somebody wasn't counting very well, and we know we sold 50 total. We know that. We know we sold 50 total, but we don't know how many of each that we sold. We know that our bike tires sell for $10 and our car tires sell for $50, and we know how much money we made total, but we don't know how many of each we sold. Wow, that's such a common problem we all face in our daily lives, isn't it? I'm joking. I am going to call bike tires B, because I'm super creative, and I'm going to call car tires C. And I'm going to write a system of equations. I always like to start with the simple one. It's like, if it's how many or how much total. So how many total did we sell? We sold 50. So bike tires plus car tires total is 50. So I like to start with that one. That's pretty easy. Now, I sold a certain number of bike tires for $10 each, and a certain number of car tires for $50 each, and add that all together, I made $1,700. All right, that's my next equation. So let's just write the sentence that I just said in numbers and letters. I sold bike tires for $10 each, so that's like a multiplication thing right there, right? And I sold car tires for $50 each. It's a multiplying thing, right? I squished it together, sorry. And that was for a total of $1,700. Now I have a system of equations. I want to show you kind of a little, another way of looking at systems of equations. Often we isolate one variable, like B or C would be in this case, and then go plug it into the other one. I want to show you a different way. So let's see here. I'm going to solve for B in both of these. So for here, I'm going to solve for B, and I'm going to subtract C to both sides. 50 minus C, obviously we can't do that. So I'm going to write B equals, because this cancels. And I can't help myself, I'm going to write it in that slope-intercept form. Even though I like the look of 50 minus C, but I'm going to write the variable term first and then the constant term second. So this is almost in y, this is in y equals mx plus b format, just I don't have a y or an x. So I solved for b. That's nice. I'm also going to solve this one for b, because I'm trying to show you something. So I'm going to subtract the 50c to both sides. And that's going to give me 10b equals negative 50c plus 1,700. And I'm going to divide 10 to both sides. I just dividing it to each term. Okay. And we end with b equals, see that? B equals negative 5c plus, remember when you're dividing two things, you can cancel zeros, 170. Do you see what I just did? I solved both of these for b. So this one says b equals this. And b equals this. And this one says b equals this. Well, if they both equal b, then guess what? Some fancy math rule says they equal each other. So I'm going to go ahead and set them equal to each other. I want you to be able to see that one up there. So I'm going to say negative c plus 50 equals negative 5c plus 170. Why? Because surely b equals b. And if this equals b and this equals b, then they can equal each other. So it's just a kind of a different way of doing it. And when I'm done with this, I'll know what c equals, and I'll take it back in and plug it in. All right. I'm going to actually add this 5c over here because, of course, I'm trying to combine my variables. Opposite operation, they cancel. 5 minus 1c is 4c's. I'm going to subtract my 50 to both sides. On the bottom right-hand side of your screen, there's a little gear. And if ever a video talks too fast or too slow, you can go to that little gear and you can change the speed. So if I'm talking too slow, you can speed me up. If I'm talking too fast, you can slow me down. All right. And divide 4 to both sides. And 120 divided by 4 is 30. So I have my c, which is 30. I'm b comma c. I'm going to pretend it's x comma y. And look at that. I sold 30 car tires. Okay, so if I go up to this original right here, and if 30 car tires plus how many bike tires makes 20? 30 plus what? 30 plus what makes 20? Sorry. 30 plus what makes 50? I love giving away the answer. 50 minus 30 is 20. I'm struggling here. I went up to this original thing, and I basically plugged in 30 right here. I can subtract it to both sides, go 50 minus 30, and I'm going to get 20. Or I can just use common sense and say, what plus 30 makes 50? Oh, yeah, it's 20. So here, I have my bike tires plus my car tires. I must have sold 20 bike tires at 10 bucks each, and I must have sold 50 car tires. Sorry, 30 car tires at $50 each for a total of $1,700. I can even go over to Desmos and graph this. I'm going to put it in terms of X and Y when I go to use Desmos because they're going to freak out if I use B and C. But so I go X plus Y equals 50. And I have to bring this way down. And my 10X plus 50Y equals 1,700. And where do they cross? 20, comma, 30. 20, comma, 30. Did we do good? Yeah, we did good. You did good. This is a very long video. I hope you learned something. And have yourself a wonderful